Hi, Dave Akins with Savvy Optics here. This is a little quick start video we've made for people who are maybe just got their Savvy Inspector into their inspection area, or someone who's not a frequent user of Savvy Inspectors but needs to document an imperfection. So hopefully this will help as you come up to speed on your new system. So this is the Savvy Inspector SIF4M. Although this video really applies to any of the SIF models, they're all pretty much the same in terms of software. So the system is a 4M, which means it has a motorized X stage, motorized Y stage, and a motorized Z stage for focus. Okay? So when I approach the system, I'm going to have some kind of a desktop, and somewhere on the desktop should be a little man with a hat and a magnifying glass. That's the Savvy Inspector software. So I'll go ahead and launch the Savvy Inspector software. And I get this pop-up that checks the version of the software that you're running. And then it goes ahead and initializes the stages in X, Y, and Z. So it's got to drive to the home position and then record that home position so that the stages are initialized and the system knows where they are. So once that green light goes away, we're ready to start inspecting. Now, here's our system. We're going to need to turn on the dome light. Typically, when you walk up to a Savvy Inspector, the dome light will be off. That's because you don't want to just leave it running because it'll wear down the LEDs too fast. So better to shut it off between uses or certainly at night. So we've got our dome light on now, we've got our Savvy Inspector all set, and we're ready to do an inspection. Now, we're going to do a little bit of a kind of a test case. So we'll say we're doing inspections. Let's say we have a lot of 38mm parts. Specification is 40/20. And when you're doing that inspection visually, you're going to find most parts obviously pass or obviously fail. And you can do that very quickly visually. But when you get a marginal part, that's where the trouble begins, right? So let's say we've got one of those parts in that lot and it's got a scratch. I can see it visually in the light box, and I want to check to see if it passes or fails for 40/20 spec. So I might come over to my Savvy Inspector, get a piece of tooling, set that 38mm part inside this 38mm circle. Most companies have tooling for their most commonly used parts. Then I'm going to set that onto the Savvy Inspector here. And I'll go ahead and hit the load button. Or if I was using a manual system, I'd just translate the stage to get the part underneath the stage. And then I move Z to get focus. The most common way to do this is to go ahead and get to the edge of a part where you've got a lot of information and set focus based on the focus of the edge. And here you can see my scratch. I'll translate over to it. What I'm going to do is clock this part so that the scratch is horizontal. That I don't have to do that, but it does make judging the length a little bit easier. And then I'm going to translate to the scratch, and I'm going to check focus. There we go. That's a much better focus for this particular imperfection. Next, I need to check my CAL file, right? Because there's different kinds of comparison standards that you can use. Today, we're going to use the Savvy CAL file. This is one that we talked about in a photonics media paper. It is based on the US Picatinny Arsenal limit standards. We take the max 10 and the max 80 and just connect a straight line on the semi-log plot. And then you can extrapolate that line up to a 120 or down to a number 5. So, but today we're going to be using it for the 10, 20, 40, 60, 80 part of that spectrum, but this is the Savvy CAL file. And so I go ahead and check that I'm using the Savvy CAL file. Next, I'm going to wind up just translating along the length of the scratch. And what I'm doing is I'm looking for the brightest point, and I'm concerned about whether or not this number here changes from 40 to 60. If it does, then that scratch is an automatic cause of rejection. And you can see down that entire length, it's always a 40, okay? So that means that I'm allowed this scratch, but in the mill system, if you have a 40/20 scratch and you have a number, or if you have a 40/20 spec and you have a number 40 scratch, it can only be 1/4 of the diameter of the clear aperture in length. So now I've got to check the length. So the way I do that is I translate to one end of the scratch. There's the end of the scratch here. And I right-click inside the viewing field. When I right-click, that's going to zero the encoders. And now I can translate that scratch to get to the other end. And you know, I might be doing a map, but that's a subject for another video. For today, we're just going to get a grade on this scratch. And you can see that scratch is 13.5 millimeters long. I'll hit end scratch and it freezes that encoder information. So now I've got the length. I just need to translate back to the brightest point in the scratch, which is here, so that I can show that the scratch at its brightest point is still a 40. So this is a number 40 scratch that's 13 millimeters long. Clear aperture is 36 millimeters diameter. So 36 millimeter diameter would allow me to have about a 9 millimeter long scratch at most. I'm at 13, so this is a cause for rejection. So I'll probably want to document that. So I'll go ahead and hit create file. I have to give it a file name. Often this is the day or the inspector's initials or something like that. And then I might have a part number and a serial number as well. And then I'll hit OK. And now I've created that data path. This one's in public demos ASDF. That'll be the folder where the images are going to be stored. And then I can go ahead and hit save data. And when I hit save data, it prompts me to say whether it's a point or a line or a cluster of digs. I'm going to call that a line or scratch and hit OK. That's going to drop that screenshot and bitmap into that folder that I just defined. So I've documented this scratch. I can go ahead and close that file. Hit home so I can unload my part. And now if I want to go get that data, I can actually go to the desktop and you can see on the desktop I've got my demos folder and here's my ASDF file, and sure enough there's my screenshot. So I can see that data, and that scratch now has been properly documented and that part is rejected. That's it. We'll have a bunch more of these videos with other features in the Savvy Inspector software, but this will get you started and get you to doing the grading of a scratch, which is the most common use for the Savvy Inspector. Thanks very much. See you later.